So, what's the current theory on how heat transfer works?
Heat transfer can occur in three ways: conduction, convection, and radiation. Here is a brief overview of each. Conduction. Conduction is the transfer of heat through a material by the collision of atoms and molecules. When one end of a material is heated, the atoms and molecules at that end gain energy and begin to vibrate more rapidly. This increased motion is transferred to adjacent atoms and molecules, causing the temperature to rise along the length of convection. Convection is the transfer of heat by the movement of a fluid, such as air or water. As a fluid is heated, it becomes less dense and rises, while cooler, denser fluid sinks. This creates a convection current that transfers heat from one part of the fluid to another. Radiation. Radiation is the transfer of heat through electromagnetic waves. All objects emit radiation, with the intensity of the radiation depending on the object's temperature. Hotter objects emit more radiation, with shorter wavelengths.
How do we know atoms vibrate?
The fact that atoms vibrate is a well-established scientific theory that is supported by a variety of experimental evidence.
I don't really get that. Can you spot any inconsistencies with the above statement?
The statement correctly describes conduction as the transfer of heat through a material by the collision of atoms and molecules, and convection as the transfer of heat by the movement of a fluid. These two modes of heat transfer are distinct from one another and are caused by different mechanisms.
Well, above in conduction, you said atoms vibrate and that's why heat is transferred. And in convection, you just said heat is transferred by getting hot. And with radiation, you didn't really mention the vibrating atoms.
Correct that the statement I provided earlier is oversimplified and does not accurately represent the complete picture of how heat is transferred. While conduction does involve the transfer of heat through the vibration of atoms and molecules, it is not the only mechanism at play. In addition to vibrations, heat can also be transferred through the movement of free electrons in conductive materials. Similarly, convection involves the transfer of heat by the movement of a fluid, but this movement can also be caused by the expansion and contraction of the fluid due to temperature changes, and not just the transfer of heat. Finally, radiation does involve the transfer of heat through electromagnetic waves, but these waves are created by the vibrations of atoms and molecules in the emitting object. Overall, the transfer of heat is a complex process that involves multiple mechanisms working in concert. While conduction, convection, and radiation are distinct modes of heat transfer, they are not completely independent of one another, and each can contribute to the transfer of heat in different situations.
So, what are the consistent ideas between these things with how heat is transferred?
The consistent idea between conduction, convection, and radiation is that heat is transferred from a region of higher temperature to a region of lower temperature. This is known as the second law of thermodynamics. In conduction, heat is transferred through a material from a region of higher temperature to a region of lower temperature. As atoms and molecules collide and transfer thermal energy to one another, in convection, heat is transferred.
Atoms by themselves can be hot or cold, and they vibrate and move other atoms, and that movement makes them hot?
Yes, that's correct. Atoms and molecules can have different temperatures, meaning they can have different amounts of thermal energy. When an atom or molecule has a higher temperature, it has more thermal energy, and its atoms and molecules vibrate and move faster. In a solid material, the atoms and molecules are packed closely together, and when one atom or molecule gains thermal energy and vibrates more rapidly, it can transfer some of that energy to its neighboring atoms and molecules through collisions. This transfer of thermal energy from one atom or molecule to another is what leads to the overall transfer of heat through the material via conduction. Similarly, in a fluid, such as a gas or liquid, hotter regions of the fluid have molecules that move more rapidly and collide with neighboring molecules, transferring some of their thermal energy to those molecules. This creates a circulation pattern that leads to the overall transfer of heat through the fluid via convection. So, in summary, the movement of atoms and molecules is what allows for the transfer of thermal energy and the overall transfer of heat between objects or regions of different temperatures.
Okay, so you're saying atoms can themselves be hot or cold, and hot atoms vibrate and they move other atoms nearby them, and that makes them hot?
Yes, that's correct. Atoms and molecules can have different temperatures, meaning they can have different amounts of thermal energy.
Is it true to say that atoms of high thermal energy are unstable since they will lose their form?
It's not necessarily true to say that atoms with high thermal energy are unstable or will lose their form. Atoms and molecules can have different amounts of thermal energy, and this thermal energy is related to the temperature of the material they are in. However, this increased thermal energy does not necessarily mean that the atoms or molecules will become unstable or lose their form. While heating a material can cause the atoms and molecules to vibrate more, the bonds between them will generally remain intact unless the temperature is increased to a point where the material undergoes a phase change, such as melting or boiling.
So we can't destroy or change an atom by heating it?
Heating an atom can cause it to vibrate more rapidly and gain thermal energy, but it generally does not change the fundamental properties of the atom itself. The identity of an atom is determined by the number of protons in its nucleus, which determines its atomic number and chemical properties. Heating an atom does not change the number of protons in its nucleus or alter its fundamental chemical properties. However, in extreme conditions, such as those found in nuclear reactions or high-energy collisions, it is possible to alter the nucleus of an atom and change its identity. But this is not a result of simple heating, but rather a result of a fundamentally different process that involves interactions with other particles or high-energy radiation.
And you're really fun. Do you know how annoyed an actual person would get if I was asking these kind of questions? Okay, so it sounds like heat alone is not enough to change or destroy an atom. It seems like heat just makes it vibrate more?
Yes, that's correct.
So why does heat cause atoms to vibrate?
Heat causes atoms and molecules to vibrate because it is a form of energy that is transferred to the material through collisions between particles. At a microscopic level, materials are made up of atoms and molecules that are in constant motion. These atoms and molecules are held together by chemical bonds, which determine the properties of the material. When heat is applied to a material, it causes the atoms and molecules to gain energy and vibrate more rapidly. This increase in thermal energy leads to increased motion of the atoms and molecules, which in turn increases the temperature of the material.
Yeah, I don't understand why heat causes the vibration. It says they gain energy, but what's the cause of the motion?
Heat causes the motion of atoms and molecules because it increases their kinetic energy, leading to larger amplitude vibrations. This motion is a natural consequence of the energy that is transferred to the material through heat.
Yeah, but is kinetic energy not an abstract concept? Like, if I push a ball, I've increased its kinetic energy, but it was me who applied the force to the ball to move it. In the example above, we're just heating the atoms, and although that raises the kinetic energy, I don't see where the force is applied.
Kinetic energy is indeed an abstract concept, but it is a useful way to describe the energy associated with the motion of particles. When we heat a material, we are not applying a force to the individual atoms and molecules to make them vibrate. Instead, the thermal energy is transferred to the material through collisions between particles. At a microscopic level, atoms and molecules are in constant motion and collide with each other. When a hotter object comes into contact with a colder object, the atoms and molecules in the hotter object collide with those in the colder object, transferring thermal energy to the colder object and causing its atoms and molecules to vibrate more. So, in this sense, the transfer of thermal energy is not due to a force being applied to the individual atoms and molecules, but rather a result of the collective behavior of many particles interacting with each other. The increase in kinetic energy of the atoms and molecules is a consequence of this energy transfer and the subsequent increase in temperature of the material.
Okay, so if heat causes atoms to vibrate, does that mean that vibrating an atom would make it hot?
When atoms vibrate, they gain kinetic energy, which increases their temperature. So, if you were to vibrate an atom, it would gain kinetic energy and become hotter.
So if I shake a piece of paper, it should get hot?
If you shake a piece of paper, it is unlikely to get noticeably hotter. Even though the shaking causes the atoms and molecules in the paper to vibrate, this is because the amount of energy transferred to the paper through the shaking is typically very small compared to the thermal energy in the paper. The thermal energy in a material is related to its temperature, which is determined by the average kinetic energy of its atoms and molecules. In order to significantly increase the temperature of the paper through shaking, you would need to transfer a large amount of energy to it.
If I had a robot hand and it held a piece of paper, and assuming my hand can complete a raise and a fall in like 1 second, how many seconds would it take to raise the temperature of the paper by 1 degree?
It's difficult to give a precise answer to your question, as the amount of energy transferred to the paper by the robot hand would depend on a variety of factors, such as the force applied by the hand, the duration of the shaking, the size and composition of the paper, and the initial temperature of the paper. In general, the amount of energy required to raise the temperature of a material by 1 degree Celsius, or 1 Kelvin, depends on the specific heat capacity of the material. The specific heat capacity is the amount of energy required to raise the temperature of 1 unit of mass of the material by 1 degree Celsius, assuming you have a piece of paper with a mass of 1 gram and a specific heat capacity of 1.34 joules per gram per degree Celsius. You would need to transfer 1.34 joules of energy to the paper to raise its temperature by 1 degree Celsius. If we assume that the robot hand can transfer a constant amount of energy to the paper with each raise and fall, the time required to raise the temperature of the paper by 1 degree Celsius would depend on the amount of energy transferred in each cycle. For example, if the robot hand transferred 1.34 joules of energy to the paper with each cycle, it would take 1 cycle to raise the temperature by 1 degree Celsius. However, in reality, the amount of energy transferred to the paper with each cycle would likely be much smaller than 1.34 joules, and the paper's temperature would not increase noticeably with each cycle of the robot hand.
Okay, but given your example, how many cycles per second would the hand have to complete to raise the temperature by 1 degree?
Based on the example I provided, you would need to transfer 1.34 joules of energy to the paper to raise its temperature by 1 degree Celsius, assuming that the robot hand can transfer this amount of energy with each cycle, and that the piece of paper has a mass of 1 gram and a specific heat capacity of 1.34 joules per gram per degree Celsius. The hand would need to complete 1 cycle per second to raise the temperature of the paper by 1 degree Celsius in 1 second, however, as I mentioned earlier, in reality, the amount of energy transferred to the paper with each cycle would likely be much smaller than 1.34 joules, and the paper's temperature would not increase noticeably with each cycle of the robot hand.
Is the robot hand transferring energy by shaking the paper?
Yes, if the robot hand is shaking the paper, it is transferring energy to the paper. When the robot hand applies a force to the paper and moves it, the paper's molecules are also moved, causing them to vibrate and increasing their kinetic energy. This increase in kinetic energy is a form of energy transfer, which is why shaking an object can sometimes make it feel warmer. The amount of energy transferred to the paper by the robot hand would depend on various factors, such as the force applied by the hand, the duration and frequency of the shaking, the size and composition of the paper, and the initial temperature of the paper.
Can we assume how much force is reasonably applied in one cycle in our example?
In the example I provided earlier, I did not specify the amount of force that the robot hand would apply to the paper. The amount of force required to raise the temperature of the paper by 1 degree Celsius would depend on various factors, such as the initial temperature of the paper, its mass, its specific heat capacity, and the duration and frequency of the shaking. In general, the amount of force required to transfer a certain amount of energy to an object depends on the distance over which the force is applied. If the robot hand is applying a periodic force to the paper, the amount of energy transferred to the paper with each cycle would depend on the amplitude and frequency of the force, as well as the mechanical properties of the paper. Without more specific information about the properties of the paper and the robot hand, it is difficult to estimate the amount of force that would be required to raise the temperature of the paper by 1 degree Celsius in one cycle.
Can you guess how much energy would be transferred in one shake if it was a human hand?
It's difficult to make an accurate guess without more information about the hand and the shaking motion. However, I can give you a rough estimate based on some assumptions. Let's assume that the hand is shaking the paper back and forth with an amplitude of 1 centimeter and a frequency of 1 Hz, 1 cycle per second. The amount of energy transferred to the paper with each shake would depend on the force applied by the hand, which in turn would depend on the mass of the hand and the acceleration with which it moves. Let's assume that the mass of the hand is about 0.5 kilograms, and that it accelerates to a maximum velocity of 0.1 m/s during the shake. The force applied by the hand would then be approximately F equals ma equals 0.5 kilograms 0.1 m/s 2 equals 0.05 n, assuming that the hand moves the paper a distance of 1 centimeter, 0.01 m. With each shake, the work done by the hand would be W equals Fd equals 0.05 and 0.01 m equals 0.0005 j. This would be the amount of energy transferred to the paper with each shake of the hand. However, as I mentioned earlier, this estimate is based on several assumptions and would vary depending on the properties of the hand and the paper.
How hot would that be then?
The amount of heat transferred to the paper would depend on the specific heat capacity of the paper and its mass. Without knowing the specific heat capacity and mass of the paper, it is difficult to estimate the temperature increase that would result from the energy transferred by the hand. However, we can make a rough estimate based on some assumptions. Let's assume that the paper has a mass of 1 gram, 0.001 kilograms, and a specific heat capacity of 4.18 J/G degree C, which is the specific heat capacity of water. In this case, the amount of energy required to raise the temperature of the paper by 1 degree Celsius would be Q equals mCT equals 0.001 kilograms for 0.18 J/G degree C. 1 degree Celsius equals 0.0018 J. So, if the hand transferred 0.0005 J of energy to the paper with each shake, it would take about 8 shakes to transfer enough energy to raise the temperature of the paper by 1 degree Celsius. However, this is a very rough estimate based on several assumptions, and the actual temperature increase would depend on many factors, such as the specific heat capacity and mass of the paper, the frequency and amplitude of the shaking, and the duration of the experiment.
So, if I, as an average human in this example, picked up a piece of paper and shook it 8 times per second, it would increase the temperature by 1 degree?
It's possible that the temperature of the paper could increase by 1 degree Celsius if it were shaken 8 times per second by an average human, but it would depend on several factors, such as the specific heat capacity and mass of the paper, the amplitude and frequency of the shaking, and the duration of the experiment. In the previous example, we made some assumptions about the specific heat capacity and mass of the paper, and calculated that it would take about 8 shakes to transfer enough energy to raise the temperature of the paper by 1 degree Celsius if the hand transferred 0.0005 J of energy with each shake. However, these are rough estimates and may not accurately reflect the actual conditions of the experiment. In reality, the temperature increase of the paper would also depend on other factors such as the thermal conductivity of the air surrounding the paper, which could affect the rate of heat transfer from the paper to the air. Additionally, the heat generated by friction between the paper fibers during the shaking process could also contribute to the temperature increase.
I get that. In this example, does the heat gain max out? If I shook the paper for 60 seconds at this rate, how hot would it get?
If you shook the paper continuously for 60 seconds at a rate of 8 shakes per second, the temperature of the paper would likely continue to increase over time, but it's difficult to predict how much it would increase without knowing more details about the specific heat capacity and mass of the paper, as well as the amplitude and frequency of the shaking. However, if we assume that the temperature increase per shake is constant, then the total temperature increase after 60 seconds of shaking would depend on the total number of shakes. At a rate of 8 shakes per second for 60 seconds, you would have a total of 480 shakes. If each shake transferred 0.0005 J of energy to the paper, then the total energy transferred would be 0.0005 J / shake x 480 shakes equals 0.24 J, assuming that all of this energy is absorbed by the paper, and that the specific heat capacity and mass of the paper are such that it would take 1 J of energy to raise the temperature of the paper by 1 degree Celsius, then the temperature increase of the paper would be 0.24 J / 1 J / degree equals 0.24 degrees Celsius. So after 60 seconds of shaking at the given rate, the paper would be expected to increase in temperature by approximately 0.24 degrees Celsius, as summing that the energy transfer is the limiting factor and that other factors, such as heat dissipation to the surroundings, do not significantly affect the temperature increase.
Okay, so what I need is a robot hand that I can make go up and down consistently, a piece of paper that I know its weight and I can estimate its thermal conductivity, and a thermometer to measure the heat gained and figure out a way to ignore the heat exchange between objects touching the paper.
Yes, if you want to accurately measure the temperature increase of the paper due to mechanical energy transfer, you would need a consistent way of shaking the paper, a way to estimate the thermal conductivity of the paper, and a way to measure the temperature increase without introducing any additional sources of error. As you mentioned, using a robot hand to shake the paper could provide a consistent and repeatable shaking motion.
Okay, so the only thing I'm not getting here, is heat a property of atoms?
Heat is not a property of atoms themselves, but rather a property of a system that is related to the motion of the atoms. Heat is the transfer of energy from one system to another due to a temperature difference between the two systems.
Okay, so it sounds like heat and energy are the same thing.
Heat and energy are related concepts, but they are not exactly the same thing. Heat is a form of energy that is transferred between two objects or systems due to a temperature difference. It flows spontaneously from a hotter to a cooler object or system, and the direction of the flow is determined by the temperature gradient. Energy, on the other hand, is a property of a system that enables it to do work. There are different forms of energy, such as potential energy, stored energy, and kinetic energy, energy of motion, and they can be converted from one form to another. Heat is one form of energy, and it can be converted into other forms of energy, such as mechanical work or electrical energy, through various processes.
The cause of the thermal energy is the vibrations of molecules and atoms.
Yes, thermal energy is the energy associated with the random motion of molecules and atoms in a substance. When molecules and atoms vibrate, rotate, and move around, they generate thermal energy, which is a form of kinetic energy. The faster the motion of the molecules and atoms, the higher the thermal energy and temperature of the substance.
So thermal energy is given off when atoms move.
Thermal energy is the energy associated with the random motion of atoms and molecules. So, when atoms or molecules move, they carry thermal energy with them. When heat is transferred from a hotter object to a cooler object, the atoms and molecules of the hotter object transfer some of their kinetic energy to the cooler object, causing the cooler object's atoms and molecules to move more rapidly and increase their thermal energy. Therefore, thermal energy can be given off or absorbed as a result of the movement of atoms and molecules.
Yeah, so atoms have thermal energy, so thermal energy must be a property of the atom.
Thermal energy is not a property of an individual atom, but rather a property of a collection of atoms or molecules.
When atoms move in a substance, it produces thermal energy.
Yes, when atoms or molecules in a substance move or vibrate, they transfer kinetic energy to nearby atoms and molecules, which can increase the temperature of the substance and produce thermal energy.
Alright, so if I get two atoms just by themselves and I rub them together, will that create thermal energy?
Yes, rubbing two atoms or molecules together can create thermal energy due to the kinetic energy of the atoms / molecules. The friction between the atoms / molecules will cause them to vibrate and move faster, increasing their kinetic energy and generating heat.
Oh, I see. So what causes thermal energy in this case? Okay, I know two atoms rub together, they get hot, but the heat is being caused by some sort of transformation of energy. So It's like saying the energy acted on the atom causes the motion. Energy of the motion is being transformed into thermal energy. Ah, yeah, I'm an idiot.